Yeah, you can go ahead though. How'd the test treat you?
Not too bad. I got a A on the multiple choice, and I think I got like a B plus on the written portion.
Nice. Very
It wasn't
good.
too.
I was actually surprised by how not tricky it was.
Oh yeah.
Like he gave us pretty simple questions. Like I thought for sure he would do the triangle inside of a triangle problem, and he didn't, which I was thankful for.
Yeah.
But yeah, good. Yeah, I'm really happy with how it ended up. I got a 98% on the right on
Ooh.
and 100% on the multiple choice, so I'm stoked.
Nice.
Yeah, so I'm happy. I'll take it.
Yeah.
Well, good. Um, how far were you able to get through the prep materials?
I. Now you mean the prep or the resources?
The the prep.
Oh, okay.
I haven't looked at the resources. Or sorry, the resources. Yeah, the resources.
So how far did I get in the resources then?
Yeah.
I I went over a few of the PowerPoints,
Okay.
um, and I didn't really get to any of the videos,
Yeah.
but it seems to be a lot of we're doing laws of sine and cosine, which it's a little bit familiar to me
Yeah.
from high school. So
That's good. It's always nice when you can refer back to that and makes a
yeah.
little bit more sense. It's easier to pick up on, I guess. All right. So I've only really been through the law of sines, and I'm honestly not even done with it, but I think I understand it.
Hmm.
It I'm guessing cosines is similar, but just with uh, its own relationships instead of sine. Like opposite over hypotenuse is sine, right? So I'm guessing cosine is just the same, but with uh, adjacent and hypotenuse.
It's a little bit different.
I guess it's probably hard to find the adjacent side length, huh?
Yeah, well, like I'm looking at the PowerPoint right now.
Okay.
So law of cosines is used when given side, 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 and side angle side. And then to find, I guess to find the law of cosines is so I guess if you were trying to find alpha, cosine of alpha, it would be a squared equals b squared plus c squared minus 2 times bc cosine of alpha.
Huh.
Yeah,
I
so
might
not
have
quite,
to look at
not
that.
quite like the law of sines.
Okay.
And then
Well, crap.
if you
How
were
have I been
to,
able to get through all this?
and then if you were to try and find uh, like beta and what is it, gamma, uh, you pretty much do the
Yeah.
same thing except whatever side you're doing, like the side corresponds with the angle. So if you were trying to find beta, it would be b squared equals a squared plus c squared minus 2ac cosine of beta.
And that's part of the law of cosines?
Yeah.
Okay. I'm gonna have to open that one up.
Yeah.
So is it just law of sines and law of cosines that we're doing today, or what's the SSA PowerPoint?
SSA.
Is that
So
another topic, or is that just another? resource.
So side
I can look
angle.
at it.
Bless you.
Oh, the side angle side. Or
Yeah.
side angle. Okay, well, crap. I wish I were more prepared today. Dang it.
That's fine.
Where is the cosines? There it is. Okay. So the law of sines is used for angle, side angle, 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 side, or side, side, angle.
Yep.
Law of cosines. Side, 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 and side angle side. I guess my only question there is what's the difference between like side, side angle and side angle side? Because they both have two sides and an angle.
I think it's just like how it's oriented.
Oh, okay. Okay. Is that arrow on the PowerPoint, is that supposed to be a power? So like b squared, a squared?
Arrow?
Yeah, so I don't know if I'm going to be able to show this. It shows like a and then an arrow pointing upward and then 2. So a arrow upward 2, is that supposed to be a squared?
Wait, what PowerPoint are you on?
The law of cosines on the third slide.
Arrow. Uh, and what were you saying again?
I wonder if it's a Mac problem actually. I'll try to show you here what it's showing me.
Okay, because the only arrows that I see are like bullet point arrows.
Okay. Look at, I can't even tell if you can see this, but I'm going to try. So,
Yeah, that is not what I have.
okay. What does it show on yours? Is it just a squared?
Yeah, so a squared equals b squared plus c squared
Okay.
minus.
That's so dumb. I'm guessing that's a Mac thing where it's just where it doesn't have the right symbol and so it substitutes it.
Probably.
Okay. No wonder you were so confused when I was asking.
It's like it's a different power because I don't know what he's talking about.
Yeah. All right, I'm gonna write this down. A squared plus b squared equals b squared plus c squared. minus 2bc cosine alpha. Holy junk. Yeah, that's weird. Yeah, I'm gonna have to write those down as well. Sorry, I'm taking time. If you wanna start looking at the GHOA assignment, you can.
All right.
I'm gonna try to just understand this enough that we can get moving. Okay. This last slide in the law of cosines is interesting. Kind of gives a layout for when you use what.
How to solve a triangle, answer each question, provide a reason why. What the?
All right. Let's try to get going on this, I guess. And I should be okay until we get to a side-side angle problem.
Okay.
So pull some stuff up.
I'm gonna go grab some water.
Okay. Okay. I guess on our team discussion is supposed to be going through the side angle PowerPoint. So
Yep.
I guess we'll start there. Were you able to go through that yet at all?
A little bit.
Okay. Well, let's walk through it together and make sure we can both follow it.
Okay. So we know two sides and one angle, but the angle is not between the sides. We know the length of the side. We don't know the length of this
The
side.
angle is not between the sides, hence side angle, or angle side. It doesn't matter which direction, right?
I think so.
Okay, that makes sense to me. All right, so we know the length of that side going up, and we don't know the length of the bottom side.
Mm-hmm.
But we okay, that's weird. So we only know one side and one angle.
Wait, we're supposed to know two sides though.
Yeah, I think we're supposed to solve for the other side
Okay.
and then use it. And I don't see why we can't just use law of sines and solve for another angle instead, because that would be easier.
Yeah.
But maybe that's not possible.
Huh.
I guess we'll keep going. Yeah, because it says we don't know the height, but we can find out using right triangle trigonometry, which is what we were learning before, where we
Right.
can use Pythagorean theorem and then the triangle adds up to 180 and all that.
Right.
So That's true. We can figure out that side, actually. So I guess technically that is a known side because you can find it using the angle and the one side, right? Because we can just do, what would that be?
Oh.
Sine of that angle equals opposite over hypotenuse. So we'd be finding the opposite. We have the hypotenuse.
Right.
So it'd be easier if we could put numbers to this. Let's move on because I think that's where it's going to take us.
Okay.
What changed here? Let's add numbers. Yep. Okay, so the side is 4, the angle is 30 degrees. So we can find the height doing 4 sine 30 degrees, right?
I think so.
Because like it'd be sine of 30 degrees equals the height over 4. And so we can just multiply that denominator over
Uh-huh. Oh, okay.
the height alone.
Yeah.
Yeah, so it should be 4 sine 30 degrees, and then we'll have the height. I'm going to go grab my calculator.
Right.
Off. Just on. Okay, sorry about that. 4 sine 30. I hope my calculator's in degrees. It is. So 2. Is that what you got?
Yeah.
Okay. So this side is 2. Oh, okay, it shows on the top in red. All right. That equals 2. Okay. I'm on slide 10.
Oh,
Where are
okay.
you at?
I will get there. Holy crap.
Are you following everything so far, or are you stuck on anything?
Yeah, no, sorry. A friend of mine messaged me on Facebook really fast, and it was uh, so past couple of days I kind of been going through depression,
Oh, okay.
and so I feel better now. I kind of had a mental breakdown over this last weekend, but I feel better now.
No, I'm sorry about that.
Yeah, that's fine. And so I every now and then I get messages from friends I haven't talked to for a while, just trying to reach out. So
Yeah,
caught up in that for a little bit.
yeah. Well, hey, it's a real thing.
Yeah.
That is, I mean, yeah, it seems to be pretty common lately. I don't know if it's just that it's coming out now and it wasn't really known before or what it is, but
For me, a lot of it's just kind of been the dating and social climate here.
yeah.
So
BYUI do, right?
Yeah, and I guess for me it just seems like I'm the only one who's not saying I do.
Yeah. Hey, I wouldn't worry too much. There's, you know, the Lord has his timing for everything and it'll work out.
Mm,
Yep. Sometimes it requires a little more patience, but
yeah,
yeah,
good at that.
we're not, we don't need to rush through life. But yeah, anyways.
All right, so write this
So,
down.
how are you struggling on any of this, or are you following so far?
I'm just reading through some of this stuff. So I'm on slide 8,
Okay.
looking at that red box.
Mm-hmm.
We can find. So cosine 30 adjacent over hypotenuse. So is the adjacent side 2 square root of 3?
Um,
Is that what it's
I
saying
guess
inside?
so. Yeah, I kind of ignored that part, so I'm glad you made me go back to it.
Oh, okay.
um, I mean, yeah, I can cosine of 30 would be adjacent over hypotenuse, so 4 times cosine 30 gets 2 square root of 3. Okay. Yeah. I don't know why you really need to know that side,
Yeah.
but I guess it's fine to know it. Okay, this is getting weird.
Yeah, it is.
This is weird.
Yeah, it is.
I'm not quite sure what the second red line is for.
Yeah, they're like talking about having two different triangles or two possible triangles. And next one, it's like triangle's all purple.
Yeah. Um, Holy cow, this is weird. The length of the side is opposite.
Side using a lot of signs. Huh.
I still don't understand the second red line. Like, I understand where the first red line came from, but now the second one seems to be more relevant, and I don't understand why or how.
Yeah.
Like, Oh, okay. I get it.
You got it?
I understand the second red line now.
Oh,
That took me forever. Um, are you making sense of slide 13?
kinda.
Okay, so here's what I wasn't getting. So it's saying that if the length of the adjacent side that we don't know, right at the bottom, if the length of the adjacent side is larger than the height, but smaller than the hypotenuse, um, then where does it end up? And so there's that first line that it shows on slide 12,
Mm-hmm.
but that line's too long. It doesn't make a triangle. It's passing it.
Yeah.
And so it's tilting it in until it does hit it.
Yeah.
Okay, I was not understanding that.
Oh.
Okay, so it can make two sides of equivalent length, or it can make two triangles with an equivalent side length. All right, maybe you understood that, but I was stuck on that.
Yeah. It's all good.
Oh, this is weird.
Which part?
I'm on slide 15,
Oh, okay.
just where it gets to the math.
Yeah. Do you get it though?
Yeah, I need to do a problem so that I see it work.
Okay.
But yeah, I'm following it now. I don't understand the sine to the -1 thing.
You mean arc sine?
Yes, arc sine.
I think like that's what you do to get alpha by itself.
Oh,
So you
yeah.
take the inverse of sine applied to both sides, so it's like
So
sine on the on the alpha side, and then you're left with arc sine times 4 sine,
Okay.
30 degrees over 3.
Okay. That, I mean, yeah. I guess that makes sense because you have to, the inverse of, like, to get rid of sine, you have to take the inverse of it on both sides.
Yep.
Okay. I'm following, but that is weird.
Yeah. Wait until you get to 18.
uh, beta equals 1/8. You know, dude, I didn't have an appetite. Yeah. What? Okay. No problem. I'm trying to understand it. It's weird. Weird stuff. So where does the 5.7 come from on slide? What slide am I on? I don't know what slide I'm on.
Is it 17?
Oh, yes, 17. Is that the bottom side?
Yeah, I believe so.
Okay. Okay, that makes sense. Holy smokes.
Did you look at 18?
I'm on it now. I haven't looked at it really yet.
Yeah.
Oh gosh, the format of this slide is unreadable.
Yeah. Makes me wonder, like, what you would actually use this for in real life.
Rocket science?
Maybe.
I don't know. I mean, I'm sure things come up that are just weird.
Yeah.
Like, I'm sure engineers use it a lot.
Mm-hmm.
But yeah, I mean, I don't know. 4, 3, we don't know that side. We do know that angle. We don't know the other two angles. Subtracting. Okay. Gosh, slide number 18. That is not easy to understand what it's saying.
Yeah, it's going
Okay.
back.
I finally understood that, like, okay, this side is 41.8 degrees, and I thought it was saying that the other angle that should be equivalent is 138.2 degrees. And I'm like, no, it's not. Okay. It's showing me the opposite side. Okay, it makes sense.
Yeah.
Find the last angle. 180, blah, 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 blah. Okay, I'm following all of that. I am on slide 21 now. Holy junk. How long are these meetings supposed to be?
I don't even know.
I feel like we're given
Here we go.
quality of
Order
material.
focus.
What's that?
I was just saying that I don't know how long they're supposed to be, but the longer we go, the harder it is for me to focus.
Okay. I understand it now. I think I could do it, but I'm going to be referring to notes a lot. So let's just try to do one. Holy smokes. Yeah, he gave us a lot to do. Okay, do you want to try to do one of these triangles from the extension problems?
Sure.
We probably ought to do one before we just jump into the quiz. Just so that we can check it.
Yeah.
All right, so let's do the first one where that's alpha, where alpha equals 39.6 degrees.
Yeah. So now, how do we determine which side is which?
Basically just draw alpha on the left for now because that's going to be the easiest.
Oh, okay.
It doesn't really matter which way it's oriented because you can just change the orientation after and it still applies. Okay. So, and it says above in that triangle that just draw it oriented like this, where the given angle is in the left side of the triangle.
Okay. And so, what about the sides?
I guess let's just go on. We'll just base it off of that triangle that it gave us in the law of sines that looks like this. So like if they give us alpha, we'll use this. If they give us beta, we'll use this. If they give us gamma, we'll use this angle.
Okay.
And then, what is it? A, B, and C. That's what he's expecting us to use here, so let's try it that way.
All right.
So yeah, we'll draw alpha in the bottom left corner. C would be
3.7 or 18.4.
18.4. Yeah, so that'll be like the one going up, and A will be the opposite side. So it gives us our opposite and let me think about that. Yeah, it gives us our opposite and hypotenuse. Okay, but C is not always the hypotenuse, and that's what it was trying to get at with the, what if this side is longer than the ones given? What if it's shorter than the ones given, right? C is not always your hypotenuse. So you can like change the orientation of your triangle however you want to make it look the easiest, but the math still works out.
Okay, so it doesn't matter what side it is?
Not, I mean, we can start it where C is on the top, and it should work just fine. You'll be able to see a problem when you compare, like, in my picture, though, this side looked shorter and it's actually supposed to be longer, you know, and then you'll realize, oh, your picture's wrong. You probably need to draw your triangle different.
Yeah.
So that it makes sense or whatever. But because, like, if we look at the second one where beta is 28.6 and then A is 40, or I guess let's look at the third one where gamma equals 32.7 degrees. C is 28.6 degrees and your B is longer than C. Like your B is your hypotenuse there. Yeah. I hope I'm not confusing you more.
Uh, I don't know. I'm just like doing the problem right now, seeing if it works.
Okay. Yeah, let's just try it out. A is 3.7. That doesn't seem possible to me. Does that seem possible to you?
What is A being 3.7?
Yeah, where A is 3.7. Does that seem possible at all?
I don't know.
Okay. I'm going to have to draw this bigger so I can explain what I think is going on here.
Okay.
Okay, so this is what we have so far,
Okay.
right?
Yeah.
Where alpha is 39.6 degrees and C is 18.4 degrees. Now, if A is 3.7, which side is A?
I would assume the side that was opposite of alpha.
Yeah, I would think so too. But it couldn't be because, well, let's just draw a triangle like that. There's no way if that's 18 that this is 3.7. And there's no way that if we keep going out this way that it's going to be 3.7, right?
Okay.
So I think our A is going to have to be this. Like, it's going to have to do like that sample question we had. On the slides there, where A is like this length, and our triangle is like this funny sliver looking thing.
Okay.
Are you seeing that?
Yeah.
I mean, that's the only way you could get a side as small as 3.7.
Yeah.
But basically what that means is this is not a side-side angle triangle. It is a side angle side triangle, right?
Side angle side. Side angle side. So that means we're doing a law of cosines then.
I guess so. Yeah. And that's fair. Like, I mean, he didn't say which one it is.
Yeah, that's true. Okay, so then we are trying to find B, side B squared plus C squared minus 2AC. Yeah, 2AC cosine beta. Wait a sec.
Yeah, it would have been nice to start with a question that's not way confusing, but
Yeah.
of course he's going to do that to us.
So now if we're trying to find side B, we're going to have to find angle beta then first.
Yeah.
How do we do that?
I am not entirely sure. Hang on. Isn't A by definition opposite to alpha?
That's what I thought.
Yeah. So what is happening here? This doesn't make sense to me anymore. I'm way confused. Side. Man, this is just not computing in my head how that's possible.
Yeah, my calculator is not computing it either.
I guess, let me think about this. Okay. It's making sense now, but I have to draw a triangle that like seems funny at first.
Uh-huh.
Yeah. I mean, it's still weird. I don't know. Holy cow. I just my mind is exploding trying to comprehend this.
It's not easy.
Maybe I'll just stop trying to draw it and I'll just use equations.
Yeah.
So I was wrong. It is an angle side side
Okay.
by definition. Just because A does have to be opposite to alpha. So
Okay. So
angle side side, which is the hard one. And all of these are that way. If you look at them, they're all
yeah.
angle side side questions, which is very convenient.
Yeah, but at the same time it sucks.
Yeah, that was sarcasm. That is
Yeah.
not convenient.
So I tried to do law of sines equation, and I keep on getting a domain error on my calculator.
Yeah.
So I don't know what to make of that.
Yeah, law of sines won't work here. I mean,
What do we do then?
we do. It's just weird. I want to see if it's solvable because I look at this and it does not seem solvable. I'm going to look at the key. This is going to drive me nuts. No triangle. Oh my gosh. I knew it.
Wait, what?
Okay. Yeah, there's no triangle. Why does he have to throw a curveball on the first one?
I don't know. What are you talking?
Okay. Yeah, yeah, you couldn't build a triangle. 3.7 is not long enough to reach the bottom side.
Oh, so you were looking at the answer key then.
Yeah, I looked at the answer key. So
Okay.
let's go back to this
Um,
guy, right? And that's what I was thinking. Like, if this is 18 and that's 39 degrees or whatever, like, there's not a chance 3.4 is going to get anywhere. That doesn't
yeah.
reach. That doesn't reach this side. Wherever, however far it goes, it won't ever reach. Okay.
All right.
Mind unblown.
I'm
That's
just mad.
frustrating. At least there's a key, but that's
Yeah.
frustrating. I'm going to make sure this next one is solvable. It is. Okay. Let's try that.
All right.
Okay. Have you drawn out a triangle, like a shape yet?
Yeah.
I think I've decided my shape. Now I can start. Okay.
Ah. Hey, hey.
Trying to figure out what to do here.
Well,
Do you
if
have
that,
to draw another triangle inside of it?
what's that?
You don't have to draw another triangle inside of it, right? That's just, I mean,
I don't think so.
okay.
I just got alpha, so
Oh, nice.
I think I'm going on the right track.
So, yeah. My wife's gonna use her laptop for a second, so I'll be
Okay.
here. But
All right.
hopefully it doesn't sign me off or anything stupid.
This file is huge. What? Alright, here we go.
Thank you. I mean, you're welcome.
Okay. All right, I got it.
I just got alpha.
What'd you get for alpha?
21.8 degrees.
Yep.
Sweet. Now we're just trying to solve the whole triangle, right?
Yeah, so you're finding alpha, gamma, and side C.
Okay, so now that we've done that, we can find angle C. Is that what you did next? Or
Yeah.
what is that? That's gamma, not angle C. Gamma.
Yeah.
Minus. Okay. Uh, Forgetting how to get the last side. You have to use law of sines again, right?
Yeah.
So I guess I'll just start going and see where I get stuck. Sorry, I'm taking a long time. I think I've got it though.
It's all good.
Imagine doing this without a calculator.
Yeah, wouldn't be too fun.
Okay, did you get 84.5 for C?
Yep.
Whee! Okay. Ugh. Okay. Let's move on to the quiz so that this doesn't eat up our entire life. Shall we?
Let's end it.
Group quiz. 3 questions. Oh, cool. And this number 1 is just like the one we just did. Did you check the key, by the way?
Yeah, I did.
And we were right?
Yep.
Good. Okay. Number 1 is just like that. So let's do it.
Come on, computer. There we go. Determine the number of triangles and solve the triangle with the given information. Do you have alpha yet?
No, I'm slow.
Okay.
Oh. I'm dumb. I added a step that I didn't need to add.
Oh.
I was wondering why I had an extra step here.
All right, I think I finished up on number 1.
Very good. You're fast. I still haven't got alpha. Did you get alpha's 45.1 degrees?
Yes.
Yay. Okay, sorry, this is great. Did you get gamma as 102.2 degrees?
102.2, yeah.
Okay. My triangle no longer looks right, but whatever. As long as my values are good,
Yeah.
I think it's fine. Did you get 51.7 for your C?
Yes.
Cool. That's good news. How far are you on number 2?
I'm solving for alpha right now.
Okay.
I'm getting close.
So this one is side, side, side.
Yeah, so it's law of cosines this time.
Well, cosines. Very fun. Okay. Why does it say determine the number of triangles when there's only one? We have 3 sides. There's only one possible triangle.
Yeah, I don't really know about that. I just don't get it. The only thing that I can think of is like going back to that one PowerPoint where they're saying like, oh, this side, if you tweak it this way and you tweak it this way, you have 2 possible triangles.
Right, but that's only because we didn't know side B,
Oh,
right? And now we do, so there's only one.
yeah,
And I mean, I'm just gonna say there's 3 sides, so there's only one triangle.
sounds good to me.
I feel like he'll understand that we understand. All right. Anyways, cosines. This is fun city. So basically, do you just have to use that formula 3 times, like each of the formulas?
Yeah, pretty much.
Okay, that's lame.
found beta.
Holy smokes.
Everything going okay?
Yeah, I'm just. It sucks that this is taking all night.
Yeah.
I don't know if I'm doing this right.
What's up?
So when you do your law of cosines,
Mm-hmm.
what's the order that you move things? Because like I'm gonna do the alpha first. So I have a squared equals b squared plus c squared. Can I just like do a squared minus b squared minus c squared equals negative 2bc cosine alpha?
So what
Is
I
that
did,
fair? Or like I don't know if I'm breaking any algebra rules.
was I moved a squared over to the other side, so I subtracted a squared from both sides, and then I added uh, 2bc cosine of alpha to both sides. So now you got 2bc cosine of alpha equals b squared plus c squared minus a squared. And then after that, divide both sides by 2bc. So you're just left with cosine alpha on one side. And then to get alpha by itself, I just did the inverse function. So
Is that
the
fair though? Because I feel like if you move a squared over, then the whole equation is equal to 0, right?
no, so you do that, but you also add a 2bc cosine alpha to the other side.
Oh, okay.
So basically, my final new equation is alpha equals arc cosine of b squared plus c squared minus a squared divided by 2bc.
I guess I probably should have finished the PowerPoint.
Well, it doesn't exactly say it in the PowerPoint, I don't think.
Okay.
It just gives you the starting equation, and then I just thought, well, let's just get the alpha, beta, gamma by themselves, and so that's what I did. And I got all three angles. Actually, let me double check real fast, see if they add up right. So 14.5. Yeah, it's roughly 180. So
Okay.
altogether, so
Man, these questions just take so long.
yeah.
So alpha is 14.5 degrees, correct?
Yes.
Yay.
Uh, number 3 is what's getting me.
Um, I just ran into a problem where I'm gonna end up with a negative here.
Oh, is that before you apply
Finding
the
beta.
time?
Yeah, before I'm not done with it, but
It's fine.
okay.
Once you apply arc cosine to it, it should come out positive.
Okay. Good to know. I was worried about that.
Yeah.
36.6 for beta.
No. I got 143.4.
Yeah, yours sounds more correct. Where did I mess up here? Oh, that's where. I forgot my negative.
Ah,
That's going to be important. $143.4. Okay.
yep.
Sorry, I still have to do gamma.
It's all good. You need any help?
No, I have to write it all down. And
Right.
it's ridiculous to write it all down, so I'm still skipping stuff, and I hope he is fine with that because this is taking forever.
Yeah.
Yeah. $22.2 degrees.
Yes.
And that pretty much adds up. 180.1 degrees, but I don't know how close he's really gonna.
It's close enough.
Yeah. Okay, cool. Very nice. 3.
And this is the one that I have really no clue what to do with.
210 degrees. when you look at 220 degrees, just think of the unit circle, and how if you go all the way around, it's just representative of a direction.
Oh, okay. So 210 degrees would actually be 30?
210 would be, well, so 360 minus 210.
Oh, 360 minus.
It's negative 150 degrees. So the inside of our triangle will be 150 degrees. Does that make sense?
Okay. So 210 degrees is actually 150, is what you're saying?
Yeah, just because 210 degrees is just like, that could never be inside of a triangle. It's over 180, right?
Yeah.
So it's just saying, like, on a scale of north, south, east, west, he's going 280 degrees or 210 degrees from whatever point, which would actually be the equivalent of negative 150.
Oh.
But we don't care about the negative because we just care that that's just, I guess, a term that they use to specify the direction, but we don't really care about the direction. We just care about the angle.
Right.
Which is going to be 360 degrees minus 210, so that we can make a triangle out of it.
Uh-huh.
After flying 12 miles to reach Interstate Highway 20, it flies along Highway 20 for a while. After then heads back to the station on course. 310 degrees. So 310 degrees, if we look at the unit circle, yeah, so that's going to be pretty close to 7 pi over 4, or 315 degrees. We don't care about that except to draw a triangle.
Yeah. So you would take 310 minus 360.
So I would take 150 minus 310 minus 360, or 360 minus 310.
Okay.
Sorry, I'm confusing.
It's
I know
fine.
what I'm saying. I just say it stupidly. Sorry about that.
Hey, as long as you understand it, that's totally fine with me.
At this point, yeah, we need to get this crap done.
Yeah.
So, or I guess another way we can do it is 310 minus 210, right?
I
So there's
guess.
100 degrees in there left over.
Because what I'm getting confused on is you said before that 210 is the same as negative 150, which we counted as 150. And then we look at 310.
Yeah, I didn't read the rest of the question yet, so I kind of led you astray there. But
Oh,
let's look at this. So 310 gets us, or 210 gets us to the first line. 310 gets us to the next line.
okay.
Can you see that kind of?
A little bit. It's kind of blurry.
Yeah, sorry.
It's all good.
Anyways, this first line on this side gets us to 210 degrees, where the line on the other side going downward gets us to 310 degrees on the unit circle, right?
Okay.
I'm just using those as a visual.
Okay.
But basically, our angle for the triangle is going to be the difference between the two. Right.
Oh, okay.
So 310 degrees divide or minus 210 degrees equals
100 degrees.
100 degrees. Okay, and then it flies 12 miles to reach Highway 20. So that first angle that it makes, or that first side that it makes with the 210 degree bearing is 12 miles.
Mm-hmm.
And that's all we have. Okay, so this is where we're going to have to bisect the triangle so that we have a right triangle so that we can get the other side length.
Oh,
And then we move on with the side angle side situation, I believe.
all right.
So keep drawing stuff too small, but this is what we end up with.
Oh, okay.
So that's 100 degrees. We're going to bisect it and use that right triangle as a reference to get that side, that far side.
Okay. Does that mean that we have to find two different triangles?
Yeah, I think. Crap, I don't know anymore. Let me think about this.
Okay.
It's not going to work. It only works if we already know one of the sides, which means we have to start 12 miles out, which means our right triangle is going to end up being larger than the triangle we're really trying to solve.
Yeah.
If that makes any sense. It's going to be an extension way out where we can make the right triangle, where our triangle is going to be somewhere in here.
Okay.
Yeah, that sucks. And I don't know if that helps us now that I think about it more. Oh, duh. Wait, I think, duh. Let me think. No, that doesn't help either. I don't know what to do. Do you have any ideas here?
Not really. I've kind of been confused since square one.
Okay, so we fly 12 miles out.
Uh-huh.
That's the only length we have, correct?
Yeah.
That doesn't say how long he flew back. That sucks. I need to look at the.
I mean, I don't know if this helps at all, but this is kind of what I did in the beginning. And I'm wondering if it'd be like any better if you took 210 and 310 and you subtracted 180 from both of those. It might come out to better degrees, but I don't know. I could just be like shooting for the stars.
Okay, so if we subtracted 180 from each of them. Yeah, I still don't know if that really helps us. Does it say anything about Highway 20? 310 degrees.
That's kind of what I imagined in the beginning. But
310. Um,
I don't know if that helps at all.
hmm. Bearing of 310 degrees. I guess I don't understand bearing. I, okay. All right, listen to this. The bearing of a point is the number of degrees in the angle measured in a clockwise direction from the north line to the line joining the center of the compass with that point. That probably made no sense at all, but so I guess north is 0 degrees.
Okay.
And so 210 degrees is going to be like this way. And then I think we take 310 degrees from that angle to get back. Or something. I'm really, that's still just throwing me off.
I hate this.
I mean, yeah, I'm not a pilot, so I don't know what bearing means. Course with a bearing of 310 degrees. Because if that's the case, then we have two angles. I'm going to assume that for a second and say it goes 210 degrees from due north. Man, this is stupid.
Yeah.
I'm not a pilot. I don't understand the bearing thing.
Should we scrap this problem?
It does say it flies east along Highway 20 for a while.
Yeah.
So, if that's the case, then 210 degrees is more than 180. Yeah. So east. And then 310. Man, I don't know. $310 doesn't get us back to where we started. From any way you look at it, 310 degrees does not get you back.
Yeah.
Maybe if I knew my east to west, that would help. Okay, I know what it's asking.
Really?
Yeah, that's really stupid, but I'm gonna assume that that is saying straight east, like due east.
Yeah.
And then we can figure out the angle. We can figure out another angle and we can go from there. But I was thinking east and drew a line to the left, which is west, so I'm an idiot. Bearing of 310 degrees back. Yeah, so I guess with bearing, you start pointing north and then turn however many degrees, but you always start pointing north.
Okay.
So 210 degrees is like, if this is pointing north now, 210 degrees is like this, roughly. And 310 degrees is like this,
Okay.
roughly. Those will be two sides of the triangle. Assuming that is due east, we can figure out an angle. So 310 minus 90. Wait, why minus 90? Minus 270. 30 degrees, 40 degrees. 110 degrees, yikes. Well, I'm just going to draw this out and finish, and just so that we have something there and we'll get partial credit.
All right. Sounds good.
I'm sorry, dude. This is stupid.
That's all good. Blame it on the
I really am not sure what he expects us to do with this, but I'm just going to roll with my thoughts now and try to get this in before 11 because it's due at 11. So
yeah. All right. Sounds good.
I'm just gonna cruise through this and submit it. So
all right.
I'll let you go.
All right. Well, have a good night.
All right, you too. See you, Tyler.
See ya.